Hey guys, welcome to our surface area lesson. We are going to focus on finding the surface area of prisms and cylinders. So first it's appropriate to just talk about what surface area even is, and essentially it's the space that covers a three-dimensional shape, right? If you were to take a piece of wrapping paper or take wrapping paper and wrap up a present, the amount of wrapping paper you need would be the surface area of that shape or that 3D figure. So essentially, it's the sum of areas of all the faces of a three-dimensional figure. And I'll put my little analogy here. Excuse my ugly handwriting right now. All right. Okay, so that's essentially what surface area is. It's just the area of the surface, right? It's exactly what it sounds like. So let's go ahead and talk about prisms versus cylinders. So a prism is a three-dimensional figure that has two identical polygon bases. So like this triangular prism here, the bases are both triangles. You can see the front here and the back are identical triangles. This square prism, we would normally call that a cube. Well, obviously cubes have squares just all around, but if you look at this rectangular prism, the top and bottom are identical rectangles, right? Or the left and right are identical rectangles. For this one, we have a pentagonal prism, and the bases are both identical pentagons, and so forth. Okay, and then as you can see, as you add more sides, these are like surrounded by a bunch of tall rectangles as well. So those are the prisms. Okay, and let's go ahead and take a little note here. Two identical polygon bases. All right, and so when you're trying to find the surface area of these, essentially all you need to do is find the area of each face of this shape and add it all up. So down here I have a formula, and that's exactly what I said, right? You're literally going to find a bunch of individual areas and just add them. And it works because they're just completely composed of a bunch of polygons, and we know how to find the area of those. All right, so that's prisms. Cylinders, you could kind of think of this as like a circle prism, if you will, but because it's all rounded, it gets its own name. So a cylinder, it's like a soda can, or just any canned food, and it has two identical circular bases. Okay, it has two identical circle bases. All right, and when we're finding the surface area of a cylinder, it's very important that we have the radius of the circle base and the height of the cylinder. Now, when it comes to the actual formula of the cylinder, we talked about this in class already about why this formula makes sense. So I will not go too deeply into that here, but as you can see, there are some familiar pieces to this formula. So I want to at least bring attention to those. So this pi r squared, this hopefully you recognize as the area of a circle. So what this does for us in our surface area of a cylinder formula is it finds the area of one of the circular bases. Okay, and the reason we multiply it by 2 then is because there are two bases. So that part of the formula covers the area of the top and the bottom of your cylinder. All right, now this part is where it's a little more interesting. So 2 pi r you might recognize as the circumference of a circle. All right. This is the circumference of that circular base. So why do we need that in this formula? Well, if you think about it, if you imagined wrapping up this cylinder, or like if your soda can or canned food already had a wrapper on it, and if you wanted to know how big that wrapper is, right? Because that's directly related to surface area. When we talk about surface area, we basically are talking about like wrapping your shape with paper or something. So the shape of the paper that would perfectly wrap around a cylinder is a rectangle. All right, and you can even try this to confirm it yourself. If you tried to cut a piece of paper to wrap around a can, it will be a rectangle. So when we think about that rectangle that wraps around our can, the height of this rectangle would match the height of your cylinder. So this is just information you'd already have. Now the top portion, on the other hand, is a little more work. If you think about it, this distance is going to need to cover the entire distance around the circle. Okay, so that's why we can find that length by doing 2 pi r. Because 2 pi r is the circumference of a circle, and the circumference of this circular base is going to be equal to the length of this rectangle that would wrap around our can. So the area of this rectangle is the height times 2 pi r. And that is why this right here is included in our formula. Okay, so basically this is the area of the rectangle that wraps around the cylinder. Okay, so I just really want you guys to understand this formula, because if you don't have this memorized, that's okay. It really does make logical sense. It's not just some magic "where the heck did this come from" formula. All right, so let's go ahead and go to the next page and do a couple of practice problems and see how this looks in action. So let's go ahead and start. Let's just actually start with the cylinder, since we just talked about cylinders, and then we'll go from there. So let's recall that the area of a cylinder has this formula. Okay, 2 times pi r squared plus the height times 2 pi r. All right, so all we have to do for the cylinder ones is just plug in information. So honestly, in my opinion, cylinder problems are probably the easiest here. So we know our radius is 3, and we know that our height is 10. Okay, so it's really important to identify those things to start with, because once you do that, you can easily just plug stuff in. So instead of r squared, I will write 3 squared. Instead of h, I will write 10. And in my 2 pi r, I will replace that r with a 3. Okay, so from here you can just simplify. So I'll just go piece by piece so you can see where everything's coming from. 3 squared turns into 9. And 2 pi times 3, I'm actually just going to go ahead and call that 6 pi. And so here I have 2 times pi times 9. So really I have 2 times 9 pi. And then here I can just say 10 times 6 pi is 60 pi. And then 9 times 2, that's 18. So 18 pi plus 60 pi. Now you don't really have to do all of this simplifying. If you wanted to type it in earlier, like into your calculator, you can, but I just prefer doing it this way. So this tells us that our surface area is 78 pi, which if I were to type that in the calculator, I would get 245.04 inches squared. And that is my surface area. So if I needed to figure out how much wrapping paper I needed that to fit around this whole shape, this is the square inches that I would need. All right. Let's go ahead and do this rectangular prism next, our little box here. Now this one is interesting. So for rectangular prisms, you have to add all of the faces, like all of the areas of the faces, but there's a fun trick that we can use. Hopefully, a lot of you guys are pretty familiar with boxes. So it's important to realize that each of these faces on this box, there's a total of 6, right? There's the top, bottom, front, back, left, and right. Each of those pairs are going to be equal to each other, right? The top is going to be equal to the bottom, front is going to be equal to the back, left is going to be equal to right. So really, we can get away with just finding areas of 3 of the faces and just double them. So let's start with this one. Sorry if these look a little ugly. Whoop. All right, so if we were to start with this one, this is one of the faces, and it matches with this back guy right there. So this one has dimensions, and I'll put my work here. This one has dimensions of 6 by 4. Okay, and let's keep moving on. Let's just start by identifying all of them. Then we have this one. This one has dimensions of 3 by 4. Sometimes it can be a little bit tricky to see what the lengths are. You just have to look at your picture very carefully. All right, and we have one more pair. That's the top and the bottom. Ooh, that kind of went off, but it's all right. Okay, so this one we'll draw it like this. Okay, and the dimensions here, this one's a little bit tricky. So this one has to be 6 because this parallel one is 6. So the long side will be 6, and then the short side is going to be 3 because it's parallel with this bottom 3. All right, and then remember what I said, right? Each of these appears on this shape twice. So I'm going to go ahead and just show that here. I need 2 of all of these. Okay, so let's go ahead and start calculating. Remember, area of a rectangle, this is a rectangle, equals base times height. So that's just something to keep in mind as we work through this. So we have 2 times 24. 6 times 4 is 24. Oops. Okay, and next we have plus 2 times 4 times 3 is 12, plus 2 times 6 times 3 is 18. All right, so now let's just go ahead and simplify this. We have 2 times 24 is 48, 2 times 12 is 24, 2 times 18 is 36, and if you add all of these together, you should get an answer of 108 centimeters squared. All right, and that is the surface area of this box. All right, one last problem. Here we have a triangular prism, so it's very important to recognize what all of the figures are at work here. So we can start with the triangles. We have 2 triangular bases, and you have to remember that the area of a triangle is not base times height like the boxes or the rectangles. Area of a triangle is in fact base times height divided by 2. So let's just go ahead and calculate this area of the area of these triangles right now to make our lives easier. The base of the triangle is going to be 10. The height is this vertical straight down, not the side length, it's the one straight from the top vertex down to the bottom. It's 8.3, all divided by 2. All right, so if we go ahead and calculate that, we would do 10 times 8.3 divided by 2. That's 41.5. I had to take a second to type that in my calculator. All right, so when we're finding the areas of these surfaces, we'll start with those triangles. We know there's 2 of them, so there's that. The next part, we have this rectangle. Now, the cool thing here is that they actually told us that both the short end of this rectangle is the same size as the short side of this rectangle. So really, we have 2 identical rectangles. The dimensions of that rectangle are 14 by 10. All right. And lastly, we have the base here. Well, I guess this isn't actually the base, but it looks like the base in this picture. This red one, this is also, in fact, a 10 by 14 rectangle. So actually, we could have tripled this one, but I'll just go ahead and write the same one since we already treated it as a separate thing. All right, so now let's go ahead and find the areas. My recording time's running a little low, so I'm going to pause the recording and do that and come back. All right, I got 30 seconds to get through this. So I filled in the area of the triangle with the information I got before, which is 41.5. 2 times 140 I got from doing 14 times 10, base times height for the rectangle areas. And then same thing for this. Then I just simplified, added all those together and ended with a final surface area of 503 centimeters squared. Okay, so just the main mistake people make here is like they struggle to find the area of the triangle properly. You just have to remember that it's base times height divided by 2, not just base times height.